continuing our class from earlier. I was obviously 20 minutes late. So what we're going to go through is the next thing we're going to go through is graphs of tan x. Okay. So what we were discussing earlier was the graph of tan x, where we put in the values and basically you're drawing the graph. So if we do a graph of y equals tan x, so I'm just going to delete this one here and I'm going to change this to tan x. So tan x. Okay, and it doesn't want it's not too there. You can see this graph here, and you can see that there are certain lines that it can't go through. There's certain vertical lines that it just can't get through at all, okay? And that's because tan is undefined. Remember the math errors. So when you go through this, these vertical lines at x equals minus 90 degrees, x equals 90, x equals 270, and x equals 450. These are what are known as vertical asymptotes. Basically, adjacent approaches zero, so opposite of adjacent is undefined. So it means tan, you cannot get a value for tan at these values, alright? So that's what we're dealing with there. Okay. It gets close to the line pi over 2. It gets close to those vertical lines, but it never actually touches them. So these are known as asymptotes, vertical asymptotes. So tan actually has a period of 180. Now what I mean by tan has a period of 180 is this. The other sine and cos have a period of 360 that we discussed earlier. But tan, however, you're a black dot going upwards, you're a black dot going upwards, black dot going upwards. Either way, every 180 degrees on your way. That makes sense? So it means that the tan function repeats every 180 degrees. So if we go to question 4 back here, we have this function here. Write an equation and the domain for each of the function. Okay, so what we can see here is that the domain, okay, usually, so part 2, for instance, is a cos function. How do I know it's a cos function? It starts off at 1 and it's working its way downwards. Now, how do I know it's not a minus cos function? So check this, alright? So if I say y equals cos x, for those of you that can't really see that, I'm currently changing this to cos x. That's y equals cos x. It starts at the top and goes downwards. Okay. Now, if this was y equals minus cos x, what you'll see is a mirror image. So if I do my next one is y equals minus cos x, you can see that it's a mirror image. Instead of starting at 1, it starts at minus 1. And when you're going through 0, a y value of 0, the green one's on its way down. That's y equals cos x. I'll turn over here so you can see the colors in the top left. And then for y equals minus cos x, it's on its way up. So you can see there's a distinct difference between the two of them. Okay. So when we go back to this question here, we know this one here. Write an equation and domain for each of the following curves. This is the value y equals cos x. The domain for a function is r. Okay. Or in this case, the domain could be, but you don't draw it any further, you can say minus pi plus pi is the domain. But in most cases, the domain is real because it continues on forever. So the domain value is r, real. This one here is tan x, okay? And in this case, the case for tan x, because it cannot be defined for pi over 2, what we say is it's real, and this means accepts pi over 2. So you can say the domain is real except pi over 2, but it's not just pi over 2, it's plus or minus pi over 2. plus or minus 90, and then plus or minus 3 pi over 2, because it's not defined for 270 degrees either. So it can be presented like this. Well, for the sake of this question, because they didn't draw it, because it's only drawn for certain parts, I could say the domain is uh, yeah, I think we'll just do it that way. Real less everything in real less plus or minus pi over 2 plus or minus 3 pi over 2 dot, dot, dot. It continues on forever, and that's the domain of the tan function. We're going to go to question 7. Question 7 is located here. Now, in question 7, you can see 3 graphs. You see sine x, cos x. Sine x is the green line. Sorry, cos x is the green line because it starts off at 1. Sine x is the red line because it starts off at 0, 0 and works its way up. And tan x is obviously the blue line. From this graph, find values of x for which cos x equals sine x. When does cos x equal sine x? Well, when does the red and the green curves hit each other? 1, 2. There's 2 values. Now, you'll see that this is roughly halfway between 0 and pi over 2. If that was halfway between 0 and 90, you would say the answer is 45 degrees. So halfway between 0 and pi over 2 is pi over 4. Okay? And likewise, what's halfway between pi and 3 pi over 2? We'll add pi and 3 pi over 2 together and then divide the answer by 2. You can get pi 3 pi over 2 divided by 2, 5 pi over 4. Okay, so that's your 2 values there. Now, next thing, when is tan x equal to sine x? So when is the blue line equal to the red line? Find out. Blue line equal to red line. Blue line equal to red line. Yes, blue. Here, which is 0, 180 degrees, and 360. But we need this in probably in radians, so that would be 0, pi, and 2 pi. And nextly, when is sine x bigger than cos x? When is sine x a bigger value than cos x? So sine x is the red line. When is the red line bigger than when is the red line bigger than the green line? Starts at pi over 4 and then ends. Red line is higher up than the green line from pi over 4. Starts at 45 degrees or pi over 4 and ends halfway between pi and 3 pi over 4, which is 5 pi over 4. So pi over 4 less than x less than 5 pi over 4. Finally, that's the answer to part 3. Now the answer to part 4. When is tan x bigger than sine x bigger than 0? Tan x and sine x have to be positive. Bigger than 0 means they're in the top half of the question. So bigger than 0 means they're above the x-axis. I'm just going to shade in this purple region here. This is where my answers have to be. Only problem is if I change the color of have to be in this top region here. Okay. Now let's look for tan x. Tan x is the blue line. Now the blue line is bigger than the red line. So if I was to go really if I was to go back to this diagram here, tan x and sin x simultaneously, you'll see a better view of it here, being honest. Okay, let's edit this. Oh, x. Now do y equals sin x. Okay, let's hope that works as well. There we are. Now, see this region here? It's very hard to see, so we're just going to zoom in a little bit. I'm going to show you why it's taller. It's hard to see from the graph in the question, but we're just going to stretch this out a bit. And you can see that the green line is always above the orange line. In this question, the blue line is always above the red line. So anywhere from 0 to 90, but not including 90, because tan is now to be 90, so it's going to be 0 to 90 degrees that happens. And then or 0 less than x less than pi over 2 that happens. But then it happens again. Oh yeah, it happens again over here. It doesn't happen in the middle because sine is negative in this part. It happens at 0 and 360, so it just happens at the very beginning. 0 less than x less than 2 pi. That's where the blue line is bigger than the red line, has a higher y value for the same x value, and it happens there, and that's 0 less than x less than whatever. Okay, and we're good. So that's the question.